4 times PC plus 2 times PC plus PC is equal to 1. So PC is equal to 1 by 7. From that we can easily calculate PA is equal to 4 by 7, PB is equal to 2 by 7 and PC is equal to 1 by 7. Or in terms of, I will call the A switch being closed as probability even A, even B, even C. So we have found P of A is equal to even A, which is switch A is closed, is 4 by 7, even B is 2 by 7, even C is 1 over 7. So these are all given. Now based on that, okay, with this being happening, if I look at the signal here, it will be random again. What will be the, how do you characterize it? What will be the density function? It can be this with some property or it can be this with some property and so on. So it is again a random variable. What will be the probability distribution? Will it be random? Of course it will be random, that is known. Will it be Gaussian or will you be able to compute some probabilities of that one? Is the question. Okay. So, for example, if you ask the question, what is the probability that x is less than or equal to minus 1? If that is the question that you want to, for the signal that you get here, that you call it as x, that random variable x is minus 1, how do you find it? Okay, that is equal to probability that x is, you can do a condition. Suppose A is closed, will you be able to tell? That is, given A, is this possible? Given A is closed, will you be able to find what is the probability that x is less than or equal to minus 1? It should be possible because A is closed means this is the one which is coming here. X is nothing but n minus 1 4. And you can find this property. This is nothing but the CDF. You can tell. So given the condition, it is easy to find this probability x takes some value. But there are 3 possible ways. So what you can do is, this can be written as, but this happens with the probability P of A. Plus right? Again, this is the total probability. You condition on 3 different events and multiply the corresponding probability of those events. And A, B, C's are at the partition. Collectively exhaustive, mutually exclusive events. So the same, what I mentioned here is what we are doing it here. In terms of probabilities, we are doing it. So how do we find out this one? I will do it. What is probability of x given less than or equal to minus 1 given A? One by one we can find it out. So what you are telling is that here in that case x will be, in that case x will be n minus 1 comma 4. So what is this probability? I know that given A, x is nothing but n minus 1 4. And I am asking the CDF evaluated at minus 1, which is the mean. So this probability will be half. B. So here what happens? X is 0 1. What is it? It is standard normal. So 0 1 means it is like this. Variance is 1 and standard deviation is 1. Okay, I am talking about less than or equal to minus 1. So minus 1 is somewhere here. I am asking about this one. Now I know only the error function table. I have the error function table of standard normal. How do we find this? Error function, what does it give? 0 to x, fx of x dx is what it gives. So this is symmetrical about both sides. So if I take plus 1 here, error function of 1 will give me this part. I want this part which is the same as this part. That is nothing but half minus error function of 1. Then probability that x is less than or equal to minus 1 given C, what is now x 1 comma 4. Then how do we find it? 1 comma 4. Can we say error function of 1? Because 1 is what I am talking about. Why? Huh? Mean is 1. Okay. Convert, it's not only that is one answer. Mean is different. It is not standard, the variance is not 1. So you have to convert it. So what is the conversion formula? To convert it, okay, minus 1 is my x, okay, small x. This is mu and sigma is equal to 2. The conversion is x minus mu by sigma. That will translate, if I want it at minus 1, subtract mean being 1, divided by the standard deviation being 2. That is equal to minus 2 by 2, which is equal to minus 1. So, finding this, that is the finding this value, okay, translates to finding the y, if I call y being the standard normal, being less than or equal to minus 1. Given same condition C, I can translate this to this. So what is this one? Minus 1. Yeah. So the same as this one. Half minus is what I get. So I am getting 3 different conditional properties. I also got PA, PB, PC. So this is what I have to do. So probability that x is less than or equal to minus 1 is equal to half into that probability is 1 over 7 plus half into half minus ERF of 1 into 1 by 4. Sorry, not 1 by 7, 3 by 7. 4 by 7. Because A is 4 by 7 probability and this is 2 by 7 plus half minus ERF of 1 into 1 over 6. So this is what the probability of this is. Now we will now apply the Bayes theorem. That is, the question is given that, okay, that x is greater than minus 1. Suppose we have made an observation and found that x is greater than minus 1. What is the probability that it would have come from A, B, C? Which is more probable? That may be the question. Or which is more probable? Given this observation, whether switch A is closed or B is closed, C is closed, which is the more probability? To find that one, you have to actually find all the properties, find the one which has the larger probability. Okay. So we are asking, what is the probability that A, given that x is greater than minus 1? So that can be written as probability that x greater than minus 1 given A divided by P of A into and x greater than minus 1 is something which we can find out. That is 1 minus whatever we have found out that. So this is what we need to find out. So, so what is this one? This will be, this again is known. What is it? Because x less than minus 1 given a is half, x greater than minus 1 given a is also half. So this is equal to half into p by a is 4 by 7 divided by this quantity, which is 1 minus whatever we have computed from the other one. So that is how we can apply the Bayes formula to get probability that switch A is closed given this condition. Similarly for find for B and C and find whichever which is. Okay. So Bayes theorem can be applied using this way of then we told that f(x,y) of x is the conditional density function of x given you are writing like this. What this means is conditional density function of the random variable x given the random variable y taking in the value small y. That is what it means. So far the condition on a given. Similarly a condition on another random variable can be put. That is how do we interpret it? This into dx is equal to probability that x taking a value x plus dx given that y equal to y. But again, see, this is a notation, that is why we are putting y is equal to y. But y is equal to y is an even which has zero probability. Okay, but what it really means is you find again the property lying between y and y plus dy, and then that is how we have to interpret it. But notationally, this is how we will put it. So these are the conditional density function of conditioned on the value taken by another random variable. So this can be written as f(x,y) of x comma y divided by f(y) of y. Where y can be anything. So what we have, the conditional density function of x given y is the joint distribution, okay, divided by the marginal distribution. Sorry. Okay. Okay, I will not put it, not this way of defining it. So this is something that is the conditional density function of one random variable given the other one. Okay. Yeah. We will do one more thing. So we will take on this. So x and y are two random variables. We see that x and y are independent if that is, this conditional density function of x given a particular value taken by y is the same as the unconditional density function of x for any given value of y. If that holds good, then we say that the random variable x is independent of the random variable y. In a similar manner, we can also define this is the range of values taken by x and y. This is how the independence can be defined. So, what we can always do is f(x,y) of x comma y can be written as f(x) given y or the other way also we can do it. Okay, like that we can do. So this is nothing but the joint density function is the conditional density function into the density function of both. If they are independent, then we can write this one as fx of x into fy of y. So, if random variables x and y are independent, then their density function factorizes into the product of their density functions. So, this is an important factor which makes many analysis simpler. For example, if x and y are independent, then suppose E of x, y. If you want to find what is this one, x, y is a function of x and y, that is in general g of x comma y. So how do we find it? It is nothing but integral over x and y. I will domain, the ranges can be depending upon the range of this one, x, y. dx dy. This is, that is g of x into fx of x comma y into this. So that we can write it as this is over x, this is over y, the range of this one. So we can write it as this. I can factorize into fx of x of y. So if x and y are independent, E of xy is equal to E of x and E of y. Then how about in general the variance? Okay. We will look at this one, variance of x comma y. Okay, x plus y we will see. So how do we write it in general? So this is mu x mu y. I will use the notation. So how is this one? X minus mu x the whole square into f x y of x comma y plus y minus mu y the whole square into f x y of x comma y dx dy. And then you have got a function which is minus plus two things will happen. Mu x into y minus mu y into x is there, plus mu x mu y is there. Okay, but mu x is a constant, minus mu x into y, if I am going to integrate it, okay, that minus mu x can be taken out. So y into f x y of x comma y dx dy is there. I am integrating, this is x into, is that x into, see if you do it this one, mu x into y if you there, this goes away, this y into this one is there. In this one it's purely a function of y. So if you integrate over x will, you will get the marginal density function of y, because x is integrated out, and that is y into fy of y, which is mu y. So this factor together will give you mu x mu y. this factor will together give me mu x mu y, and these two will give me plus mu x mu y. So you will have minus mu x mu y, one more minus mu x mu y plus mu x mu y. This already I think I have done this one. So these two goes away. So this factor, what remains is xy into this one. What will remain is that will be x into y will be there. This into this is what got this one. Minus mu x mu. That this is what we usually write it as, or this term is what? Okay. This term is nothing but, you will see this term and so on. This term is again purely a function of x. And if I integrate it over x and y will go, when you are integrating it over y, it goes away. The remaining thing is nothing but variance of x. This is variance of y. And this term, what we have got remaining, okay, is what is called as the covariance, 2 times the covariance. So what you will have variance of x plus variance of y plus 2 times this function, which is called as the covariance of x comma y. Now, if x and y are independent, then this factorizes to fx of x and fy of y. And that what we can do, we can separately take it out and this factor, separately take it out, and this becomes nothing but, not this factor, together is covariance of x and y. So this factor so if you look at this one, if you factorize it, x into fx of x dx, y into fy of y dy, it becomes like, because this factorizes. If and then you can separately take x, fx of x dx, and then y fy of y dy. Separately two things can be taken. Okay, this is e of x. Okay, sorry, that can be done. This is nothing but e of x comma y, e of x minus mu x mu. But this also, because it factorizes, this e of x comma y also becomes e of x into e of x, because it separately factorizes. So which means that for the case when x and y are independent, this covariance of x comma y becomes equal to 0. So variance of x plus y is equal to variance of x plus variance of y whole square. So in general, this factor covariance of x comma y, if it is 0, we take x and y are uncorrelated. If they are uncorrelated, variance of x plus y is equal to variance of x plus variance of y. If it is independent, definitely it will hold. So we say that if x and y are independent, they are uncorrelated. But if they are uncorrelated, they are not necessarily independent. So this is about the next aspect. So independence and all those things. Then we will quickly go through function of a random variable. X is a random variable. You can define a function of the random variable, you call it as g of x. Then how this will look at? It will have a density function and CDF. Okay. Let us say this is what we are first looking at. Let us say the function g of x has the form like this one. Okay, that is, it is confined. This is x, this is g of x, and this is the y-axis. We will call this as y1, this as y2. Then, to find y, any given CDF or any probability distribution condition on y, we have to find an equivalent condition on x. And probability that y takes value in this range is the same as the probability x takes a value in the corresponding range, that both conditions are met through this connection of due to this function. So here, probability that y is less than or equal to y2. See, this is y2. If I take any value of y above this one and ask what is the probability that y is less than or equal to the value y, means correspondingly x can take any value. For all those things, y will be less than y2. So for any given y which is greater than y2, will be equal to 1, because for all x will lead to a value of y which is less than y2. So for any y which is greater than y2, this will always hold. Similarly, if I ask for any y here, and what is the probability that y, random variable y, will take a value less than this one? No value of x can map to a value of y which is less than this one. So this is how we have to find it. Suppose I take a value of y here, y3. Okay. What is the probability that y3, y will take a value less than or equal to y for y is equal to y3? I will as well put y3, will take a particular value. Then I have to find those values of x which will satisfy this condition. So from minus infinity to this one, and will satisfy, and this range will not satisfy, so this range will satisfy. So I have to find, I will call it as A, B, C. So this is nothing but probability that x is less than or equal to C, plus probability that x lies between A and B. This is how we have to find dx. Sorry, here A, this is A, this is B. Then for a function which is linear, it is easy to find. Suppose y is equal to ax plus b. How do we find the, given the CDF of x, how do you find the CDF of y? Let us say a is a positive value. Then the relationship between x and y will be like something like this, right? Then if I ask what is the probability that y is less than or equal to y, this is the value of y. What is the probability that y is less than or equal to y? I have to find the corresponding x, and for all x less than or equal to x, y will be less than or equal to x. Okay. So what is this x corresponding to this one? It is the g inverse of y. Okay. So that is equal to probability that x is less than or equal to y minus b by a. Okay. So if a is greater than a is less than b, then the equation will be like this one. And for if I am giving any value of y here, probability that y is less than or equal to y will be corresponding probability that x is greater than that value. Okay. Y to be this is y should take a value less than this one. Okay, that will happen only when a takes a value greater than x takes a value greater than. So that is how you can relate find the CDF of y in terms of CDF. Is this clear? Okay. Y taking a value less than or equal to this y corresponding to x taking any value here. For any value here, y will take a value less than this one. So x has to take a value greater than y minus b. So this way you can find. So finding a CDF, mapping a condition of y to a condition of x for finding CDF is rather easy, I would say, like this. But density function will be little more involved. We will see how it can be done. If it is a linear function, again it becomes simple. If it is a non-linear function, y is equal to x squared, then it becomes we have to pay a little more attention for that. So we will stop at this point. So you will have your quiz on Tuesday.